Okay, folks, today is Monday. It's Memorial Day. We are about day 3, I think, of working on this or servicing this Honda, maybe even longer. We just haven't been consistent on the repairs because it's not necessary. Actually, the people were supposed to come by and pick it up last Wednesday, but they were a no call, no show, so it no longer became a priority. However, still, consistent on it. It's actually kind of a good thing because what we found is after we replaced the compressor, which would be diagnosed as being bad. Just want to take a look at it here real quick. If we look at the eye, looking at it from the top, I know exactly what I'm looking at. But if you look at the clutch versus the pulley, see how there's no gap? Well, and it starts to gap a little bit around there. This is locked up. The compressor, it's locking up. It's no good anymore. When you try to turn it, making really bad noise. Actually, what it is the pulley is what it looks like. The bearing in the pulley was bad. And I went to wipe my hands, but notice there, the bearing in the pulley was bad. As a matter of fact, I've had just one of these recently where I had to replace on a Nissan Altima, 2013 Nissan Altima. Same thing, compressor pulley just locked up. It came apart just like that. But at any rate, initially, as I stated before, this vehicle came in with a complaint that the alternator was not functioning properly. Sure enough, the alternator was not functioning properly. We had to disassemble the grill, the top cover here that goes across the center radiator support, and we had to remove the radiator, and then the alternator, as power steering pump is here, alternator sits just underneath there, right here. Okay, and then underneath there is our AC compressor. If you look all the way down at the bottom with the two let's see here, I'm trying to point at it, my finger is not in the frame, but right down there you see the let's see if we can, there we go, down at the bottom there with the nut, 10mm nut and 10mm bolt. You have your, on the bolt side, you have your low pressure suction side, and on the side with the nut, you have your high pressure. This is a 1-wire compressor with a thermal switch mounted in the top. Actually, I just saw a little bird. I'm sorry, I was wondering what that was that flew underneath that vehicle over there. A little Subaru that we have over here. And I always keep forgetting the name of this car. Sidetrack. It's not a Justy. I don't know what I keep. Forester. I can never remember. It's not an Impreza, but it's a Forester. At any rate, back to the Honda. What we just now discovered, and I'm going to show this on video here in just a moment once I start it up, was what I have done is, so what we did, I'm sorry, back up. When we installed the compressor, we went ahead and vacuumed the system down. We got a good vacuum on it, it held vacuum, so we had no leaks. Replaced all the O-rings in it. We also replaced the here, the expansion valve is in there. We replaced that as well. Replaced the Schrader valves and your high pressure port, as well as your low pressure port. We also replaced the belt because the belt popped on it. I think we mentioned that in our previous video, where after the compressor locked up, it shredded the belt. So after we performed our vacuum test, we decided to go ahead and shoot it up with Freon. We started putting Freon in it. We noticed the compressor didn't come on. So we're trying to figure out why. That's been the bulk of our diagnosis here for the past few days. And we're doing it kind of the Renaissance way, so to speak, the old school way, because we don't have our equipment here at this location. But we will here shortly. Nevertheless, where we are in the process now is trying to diagnose why the compressor won't come on. What we've discovered in understanding how this system actually works, we just kind of run down our electrical portion of the system. This here is your AC compressor, or your AC clutch solenoid. Let's pull this out and take a look at it, and I'll explain why I have this wire on that terminal in just a moment. So here we have 4 prongs inside this relay, and one of them is constant power. As you can see, what I'm using is a sort of a generic version of a power probe, but it works the same way. So what we do is we hook our positive cable of the probe up to positive battery power, hook our negative up to negative battery power, and it functions not just as a test light but also a voltage meter, and it also functions as a continuity tester, as well as a ground tester, so we can test for ground, positive, voltage, and continuity. Nevertheless, here we are. What we're doing is we're going to identify the prongs inside of for our AC clutch relay. Here is 12 volts, constant 12 volts. This is with the key on, or key off, I'm sorry, 12.7 volts. So we know right off the bat that we have our 12 volts coming into it. This connector here, a prong rather, is for the compressor itself. This is ground. And the reason that this reads ground is because we're going to go out in a moment. Well, I'll come back to that. This is the compressor wire. The wire that goes directly to the compressor reads ground. This wire here is ground as well. This wire here, or this port, I'm sorry, this is ground. This wire here is from the computer. So when we turn the key on and we turn the switch on, this wire should go to ground. It does not. So what we'll do is we'll go and turn the key in the on position. We'll come back out and check that to verify my claim. So now we have our key in the on position. Oh, sorry. Let's make sure we have the AC switches on. So we're going to turn our fan on. AC switch is already on. Just make sure. Come back outside. We are not getting a signal from our computer. Okay, so what we also did, and so let me go over to the old compressor to show you how this system is set up a little bit differently from some of the other systems where the thermal switch, where the connector to the compressor has a two-wire connector. This has a one-wire connector, and this is your one wire that goes into the compressor. The way that this works is, say for example, this thermal switch here was malfunctioning, not working properly. If you sent power through this wire, this clutch would not engage. But if you notice, you'll see several wires on here. If you're trying to figure out why this only has one wire to the compressor but has several wires on here, the way that this is wired is, so this wire that comes from the harness that powers the compressor goes into the thermal switch. Then there's another one comes out that's red that goes up to the, I'm sorry, you have your thermal, your power wire into the compressor, comes down to your thermal switch, and then you have another wire that comes out, a red wire that comes out of the thermal switch to power the clutch, goes down to the clutch. Clutch has two wires on it. One is ground and one is for power. The green wire comes off of there as the ground wire, grounds to the body of the compressor, which the compressor grounds to the bracket that's attached to the engine, and then you have the battery ground that's grounded to the engine or transmission. But again, the engine and transmission is grounded. So the body of the compressor provides ground for the clutch, the ground on the clutch. And then the power wire comes in this way from the harness. Now, I think we've explained that well enough, but back up. If this was malfunctioning, the compressor would not come on. So we don't have to really worry about this, and I'll tell you why in just a moment, because we actually tested it on the new compressor, which shouldn't be be malfunctioning, but there's always a possibility for anything. What we did was to determine whether or not the compressor was actually functioning properly, what we did was we jumped the wire. We use a jumper wire between 12 volts ground and the compressor, which is grounded. Remember, we talked about this. So right now, because the compressor is mounted to the bracket and the wire that goes to the compressor is attached to the thermal switch and back through the clutch and so forth, we know that the clutch is grounded properly. Now what should happen is the clutch is going to short, or it should short, when we put 12 volts to that circuit, and that's what we're about to do. So I'm gonna grab a pair of needle nose pliers here, and with the engine on or off, it won't matter. What we're gonna do is we're gonna touch these two terminals in here and listen for the clutch. You hear that? So what we know is that we don't have a malfunctioning clutch, neither do we have a malfunctioning thermal switch, and we also know that we have continuity from the wire that goes into the back of this fuse panel, the underhood fuse panel, down to the compressor. So we know that that circuit is okay. We also know that we're getting 12 volts into the relay. We also know that we're getting our relay is grounded as well. But what we don't know is whether or not we're getting a signal from the computer. Now, this system has been a little difficult for me to diagnose because, again, I don't have my wiring diagrams. But what I was able to find was I was able to find a wiring diagram online that led me to that helped me able to diagnose the system electrically for any continuity issues or voltage problems or voltage drops and so forth. The AC pressure switch is located down there. I've jumped that, and I was also able to take voltage readings off of it with the key in the on position, or the key in the off position with the on position. And what I gather is that that's pulse width modulated based on the two different voltages that I got. No worries. What I also discovered in this was that the ground, again, wasn't coming from the computer. I don't remember if I already said that, but what I will tell you also was just now, so what I also wanted to do was check to find out whether or not this thing had the coolant temperature system, coolant temperature sensor was functioning properly, telling the computer what the temperature of the engine was, or the coolant was. Because if that's malfunctioning, it will also won't turn on the compressor. But I'll tell you what I did discover that was more interesting than anything. I'm going to go ahead and plug the scanner back up for this, to just for documentation purposes also. Because a lot of times when a car comes into a repair shop, if you give a customer an estimate and you base it on your preliminary diagnosis, you don't really know until you dig into it what's really going on with it. Now, what we do know for a fact is that the compressor was locking up. Mechanically, it was locking up. We don't really know why. Or actually, we thought it was locking up, but what it was is the bearing on the pulley had come apart. So we had to replace it. So let's go back here. Let's turn our scanner up, turn our key in the on position, turn our AC switch off, get our scanner fired up here. Let's see what we got. After dusk, mosquitoes are relentless. They do not show any mercy around these parts, and that's enough to run me away. But I gotta get something done, so get something completed. So we're gonna try to stick it out a little bit. Besides, I also sprayed on some lemongrass and something, some type of repellent with lemongrass in it. Nevertheless, let's get back to diagnosing. Okay, so what I wanted to look at was the data stream, because I wanted to find out when I turned the controls on if the computer was recognizing any commands from the AC controls. I'm not quite sure if they are, but I'll tell you what, we'll fire this up and show you what we did discover. Let's see here, I'm gonna spray a little more. Let's see, what is it? This stuff here. Lemongrass and eucalyptus. All right, so we're gonna go start this up. Oh man, I forgot this thing always turns off because the battery is dead. Gotta replace the internal battery. All right, going through all of our prompts to get the scanner loaded for what we're looking for. Sometimes it's really slow. It's gotten a lot slower lately. I don't know what the deal is. Probably just because it needs updates. Okay, so here we go. We'll look at our data stream. And basically what this does is it gives us live data on what the computer sees from the engine, transmission, and all systems that are currently running while the engine is, key is on, the engine running. It's taking a moment to load here. A little sign of an engine. That's what an engine is doing. I think that's pretty cute, the animation. All right, so here is what I saw that I thought was interesting. When it starts to giving me data, it says that the AC pressure is 0. It says that the AC switch is off. Now, currently it is off, but I'm going to turn it on. This is your blower motor switch. But when you turn the blower motor switch on, the AC switch automatically comes on. I turned it off, now I'm turning it on. Notice it's on. But the scanner is saying that the AC switch is off. It also says that the AC switch is reading 32 degrees. It also says that the AC switch is also 0.0 volts. It also says that the AC temperature is negative 40 degrees Fahrenheit. So to me, when I see this, I automatically think to myself, something between this controller and the body control module and or the computer is not reading what needs to be read. But here's something I also noticed that I found a little interesting. I went out here to power the fan on because I wanted to know whether or not the AC fan was working. Let me go ahead and put this relay back in. Okay. So here, what I'm able to do is, this is the harness for the condenser fan. I'm going to back probe the wires in the harness. That is 0, which is ground, and it's green. The light is green. That tells me that the ground for the fan is actually working properly. This is the blue wire, is your power wire. Now there's nothing on it, but I can give it voltage right here. That's ground. That's 14.2 volts. The fan does not come on. Notice that. The fan is still. So what that tells me that this fan is bad. And I also, so what we know is that we have a bad condenser fan at this point. When the coolant fan turns on, the condenser fan doesn't even come on. Maybe it should come on low speed at least, but for the most part, it doesn't work at all. So what we do know right off the gate is that we have a bad condenser fan. But this is, the reason that we recorded this is because oftentimes in this industry, for various reasons, sometimes we do diagnosis technicians no matter how long we've been on a job. Other times it takes us a little bit longer to diagnose because we want to be thorough and not throw parts at a job. And in this case, the vehicle didn't have to move immediately. If it was cleaned up and ready to go, it probably would sell immediately though. But and again, here we are. We have 2 problems now that we have to run down. We have to run down why the controller is not communicating with the computer to tell it to turn on certain things. The only thing it appears to be turning on is the blower, and it's turning on all the actuators behind the dash. So we're going to find out what the deal is there. Maybe it was something that wasn't plugged back in when I put the dash back together. It could be all on me, or it may not be on me at all. It may just be that there's something else that we got to fix. So at any rate, we're going to possibly try to go up to O'Reilly's. I think they're about to close. It's almost 8 o'clock, I think. They close a little bit later, earlier on Sunday, I don't remember. But we're going to try to find out why this thing is not communicating with that. There's only one wire on the back of this controller. I do remember that, and it's on there because otherwise none of this would come on. But the question of why it's not communicating with the computer is something that I'm more interested in. And it may just be syncing up some overlooking. But what we do know is that we're not getting any readings on our scanner for any of that. And that's not okay. So we got to find out why we're getting these readings. So what we'll do is we'll play around with this for a minute. We're going to go get some power steering fluid for this thing so we can move it around the lot easily. We're also going to see what a condenser fan costs. We're going to go drop off our loaner tools as well, and we'll be back. We'll see what we can come up with. Till then, we're out.